Hey there, this is John Bishop here with my good friend, Dr. Nancy Flournoy and Virginia. We're going to get right into Nancy's presentation today on the Lifewave X49 patch. I'm sure we're all excited to find out some really intriguing things, through Nancy's talk. So, Nancy, I'll give you the floor, and you can take it away.
Thanks, John. I'm really happy to be here and able to share my findings with all of you who are interested in the Lifewave patches. The X49 is the most recent patch, and so I'm learning something every time I look for it. So just a word about myself. I am a Distinguished Professor Emerita at the University of Missouri. My doctorate's in biomathematics, and I spent my research career in clinical research primarily, biological research, biomedical research. And so I have a strong scientific background, and I still was absolutely dumbfounded to learn all that I didn't know when I started to learn about the Lifewave patches. And so these talks are a way of my educating myself and sharing that information with you. So with that introduction, I am going to share my screen. Well, yes, I share my screen. Let's see. Okay. Share screen. Okay, so hopefully you're seeing my screen now, and I will start the show. Well, that doesn't seem to do it. Oh, here, let's just go from the beginning. Whoa. Ah, here we are. Oops, okay, it's coming into view here. This is the talk about X49. That's the newest patch from Lifewave, phototherapy patch. It was released in 2022, so we have just a little bit more late. That was in late in 2022. So, well, maybe it was early. We have about a year's experience in it, so it must have been early 2022. They had some pre-releases, must have been in before the end of the year. It's been around for about a year, so we're very excited with what it does and how it adds to the Lifewave family of patches. And in particular interest, this is a second copper peptide enhancer from Lifewave. And so X39, which was the last talk that I gave, also had carried copper, and we spent quite a bit of time talking about copper. We'll spend just a little bit of time talking about copper in this talk, but we will talk about other things that this patch does for us. So let me just start by saying that of all the patches are patented. They're proprietary form of phototherapy that's targeted, passive, wireless nanotechnology, and there are nano antennae that communicate with your body with no drugs, chemicals, or stimulants. So it's a great alternative to the pharmaceutical establishment approach to things. Up here on the left, you have a little picture of what the patch looks like, just a little Band-Aid size patch that you peel off the ends and stick it on your body. It's no more than 4 centimeters in from one end to the other. And what we want to explore today is exactly what was this X49 patch designed to do, and does it do it? So those are the basic questions. Now, all of the patches are crystals. So on the little patch that you stick on your body is a a solution that is dried into a crystal form that's made of amino acids. And those amino acids, of course, our bodies are full of amino acids. So the amino acids are picked to match, to resonate with certain molecules in our body. And when our body heat gets close to those patches, the crystals start to radiate their particular frequencies back into the body. And this is all constructed very carefully to influence specific photoreceptors in the body. So the aim is to increase some particular product in our metabolism. And in the case of X49, it's designed to increase a peptide that includes copper. Cu is the abbreviation for copper. So the name of this peptide, which nobody says in its long form, is AHK-Cu. Well, we'll compare it to the X39 in a minute. But the first question is, does the patch do what they set out to do? Does it do what they claim to do? And the answer is a resounding yes. So we have a number of studies that confirm it. We're fortunate with this patch that it is readily there's a lot of it in the blood. So it's easy to get samples and, well, actually, the scientist here that did the study says it's very hard to measure in the blood, but at least it's measurable, which some of the patches are designed to do things like deep inside the brain and in other parts of the body where it's just not really feasible to get a hard measure, and you have to infer what the patch is doing from secondary sources. In the case of AHK, we have 3 studies here that all confirm that the patch increases the AHK copper concentrations. And I don't know that they're all these talks, we don't have to go through them in detail, but the results of these studies are all on the Lifewave website under science. So as I say, the point is it does what they said that it was going to do. So why do we care? Well, let's talk about the GHK copper peptide, which was our last talk. It's elevated by X39, and the AHK, which is elevated by X49. So here's your a little chemistry talk for the night. The 2 molecules look quite different. One thing that they both have that's not so common in some of the other molecules that I've shown you is a lot of nitrogen. So nitrogen is N. So if you remember, the backbones of these molecules are all copper, all these Cs. There's so much copper in the skeletons of these molecules in our body that usually, as on the right, nobody bothers to even write them down. Every little point here is a copper atom that they don't even bother to mention. So usually these molecules are written like the right, where all they do is bother to tell you what's hanging off it that's not copper. And H is hydrogen, O is oxygen, N is nitrogen. And there's a few other things that show up now and then. These are common, and nitrogen we'll come back to is important, particularly for what we're going to see the benefits of the AHK. Now, so there's a couple things to point out here in the X39, in the GHK peptide. This little Cu, this is the copper sitting right in the middle. And so you can imagine this molecule all wrapped up around the copper and taking this copper where it needs to go. And over on the picture on the right, you know, we're told it's a picture of AHK copper, but there's no copper in the picture. So I'll show you another picture later that shows you the copper. But what I want to show you from this picture is this circle right here, this little ring. And this is a very, very important ring I'm going to mention on the next slide. I think it's the next slide. Oops, maybe it's 2 slides down. Right? Okay, so here's the ring right here. It's got a name all by itself. It's called the imidazole ring. And the peptide we're looking at is called a tripeptide because it's actually made of 3 different individual peptides that come together. And one of those components is histidine. And this ring is part of the histidine amino acid. So histidine by itself contributes to protein structure and activity. And it has a lot to do with the use of not only copper, but also nickel in our body. I actually found a lot more written about nickel than about copper, but that's maybe for another talk sometime. This ring is responsible for proton buffering. So what does that mean? That means it's responsible for the pH of our body. Our body is, well, not quite neutral between acid and base, but pretty close. And if it gets too acid, you're going to have, it's going to be susceptible to bacterial and viral infections. And it gets too base, it's then got other difficulties. And you want it to be, you want your body, all the parts of your body to be in proper pH balance, just like a swimming pool. That if it doesn't have the right amount of chlorine in it, you've got this bacterial growth going like crazy. The same thing is true with your body. So this ring is really got a big role to play. It's also important for chelating metals. So that means that if you have some metal toxicity and you need to get it out of your body, this ring is going to play an important role in helping you do that. And it has antioxidant properties, which we've been learning a lot of things do. So it's another form of antioxidant. So this is the histidine part of this molecule. This ring, just to say a little bit more about it, well, it also appears in the carnosine, for which we have a carnosine patch. So the carnosine patch would carry these same benefits. It has pharmacological actions, which here there's this long list. You can see it's, what does it not help? Certainly if you don't have, it's antifungal, antiviral, anti-ulcer, anti-parasite, anti-cancer, pro-cardiovascular, anti-inflammatory, analgesic. So it's got a lot of good things for it. And that's itself pharmacological, meaning molecule to molecule actual interactions. And then it also works to catalyze certain activities that go on. And as a catalyst of other things that are being produced, it's antibacterial, anti-cancer, vasodilating and vasoconstricting. So if you're talking about your vascular system, it's doing both dilating and constricting. That means it's really managing the vascular system in a major way, or it's a catalyst for the vascular system being in a good shape with respect to how to its balance. So that's just this ring. Now, the second part of this molecule is lysine. And lysine is really a crucial component of many proteins. It's prevalent in meat. So you normally will have a lot of it in your body unless you are a vegetarian or vegan, in which case you should be paying attention to getting a sufficient amount. It helps the body absorb calcium, iron, and zinc, and promotes collagen growth, produces enzymes, antibodies, hormones, supports the immune system. It's this molecule here also with a lot of nitrogen in it. And if you don't have enough lysine, then you'll have fatigue, poor concentration, you're going to be irritable and nauseous and get red eyes and lose your hair. You may be anorexic. Your growth is going to be inhibited. If you're young, you can get anemic and have problems with reproduction. So good to have your lysine. Now, the third component is alanine, and this is the one we're going to focus on more, the component we're going to focus on more, because every time David Schmidt, the CEO of Lifewave, talks about the X49 patch, and every time he mentions AHK copper, he always adds, and alanine, don't forget alanine, which tells us that the patch was designed with the benefits of alanine in his mind, that maybe more than the other two components, that alanine's role in the body is what he was after the most. So we will spend several slides here on alanine. So this is kind of the overview. This is like an overview. I'm going to show, as I say, several slides on this really interesting molecule. So first, it helps with converting sugar into energy. And it's involved in something called the glucose-alanine cycle. And I have a slide or two specifically on this topic, which is relevant to managing sugar in your blood, as well as getting energy from glucose. It helps the liver detoxify the blood. Well, again, we're looking for a healthy vascular system. This is important. It plays a role in actually forming carnosine, which we have a whole talk on carnosine in connection with the carnosine patch, and a couple of other things here that include the B vitamins keep coming up in the descriptions of what alanine is relevant in making work and forming. It helps with acid metabolism. This is consistent with the histamine molecule doing its buffering. So here we have something that's actively helping with metabolizing acid, and it increases immunity. So there's this whole little write-up in orange here that talks about it's facilitating the metabolism of tryptophan. And why do we care about tryptophan? Because tryptophan is used to make proteins, but it's also a precursor to a lot of important things like serotonin, melatonin, and vitamin B3. And we have other talks that go into the science around the importance of the serotonin and melatonin that I would encourage you to look at if you want further discussion on that. And not only does it help you build up these compounds, but it also breaks down the tryptophan and the vitamin B6 to help you process it out of your body if that's what it's needed. So alanine itself then also provides the brain and the central nervous system with energy. Now remember, getting support into the, through the blood-brain barrier and into the central nervous system is no small feat. And so we don't have our blood system penetrating into these depths. So this is important. It helps build muscle and repair muscle tissue. It protects cells from oxidative damage, and also helps maintain normal cholesterol levels. So back to, I probably should have put that one over here with the energy comments. The sugar management comments. So alanine is a big player. Now, another slide before I give you what I think is the interesting picture. So these are just words, and then I'll give you a picture. So this is somewhat repetitive, just to make the emphasis that it's playing a role in the management of blood sugar levels. And this management, the role that it plays is done in the liver. And this is what I'll show you a picture of. And it involves, a lot of the studies about it involve the relationship between the liver and the muscles, although alanine is important in other tissues as well. A lot of the studies involve its relationship with starvation, how your body is going to use your muscle, is going to break down your muscle to use it when it really needs it if you're really hungry, and also in extreme energy. So it's an important source of energy aside from glucose. So by that I mean, you can eat your sugar and it's going to go right, and if you need the energy, your body is going to pick up that sugar and use it for energy. But here we're talking about helping the body use the energy when it needs to take it from your own body, as in the muscles and the fat and other tissue. Perhaps you don't have any sugar sources around, and you need to use your own body. So it's used to construct proteins, build muscle mass, as well as take it away. And high levels can protect against muscle wasting. And then, I don't know, David Schmidt, again, the director, founder and CEO of Lifewave, is really focused on the sports activities. And so whenever there is a result about physical performance and recovery, we're sure to find it from, we're certainly going to learn of it from David. So here's the picture I've been promising you. And it's the first one. This is called the glucose-alanine cycle. And on the right, we have a muscle, and on the left, we have the liver. And between the two is, you just think that's your blood system, that's your vascular system that's going to take molecules between the liver and the muscle. And in particular, it's going to take glucose from the liver to the muscle and alanine from the muscle to the liver. And so in doing that, blood's in between. So it's either when glucose comes out of the liver into the blood, it doesn't have to go into the muscle. It goes into the blood system, and your body's going to use it for energy if it needs it or whatever. And if the tissues need it, then it'll go into the tissues. And so I want to tell you several things about this particular slide. The first is that when we think of the liver, I think most of us think of it as part of our waste disposal system. You know, things are, the antioxidants going to go around and collect all the garbage, and the lymphocytes are going to go around and collect all the garbage. And we have our whole waste management system that's bringing things to the liver to be processed, to be excreted through our bowels, and you see urea here. And the liver is, of course, critically important for that. But what I didn't appreciate so much, but I'm learning to appreciate more and more, is that the liver is not only the garbage disposal system, it is the recycling system for our body. So what we have are molecules being sent from other parts of the body that are getting recommissioned to go back out for new use. And the recommissioning in this picture is showing something that was, rejected from the muscle, either maybe drawn out of the muscle because you were starving, but maybe rejected from it because it wasn't needed anymore. And it goes back into the liver, and it's reconstructed into the glucose so it can go out and provide energy to your body when your body needs it. So that's so that was a kind of a new image in my mind, was to think of the liver as my recycling system. And on the next, so this is the one path here that we see. This intermediate molecule pyruvate is kind of a stripped down alanine. So remember, you have this carbon, you have this all the carbon molecules linked together, and you have stuff hanging off of it. And to get from alanine to pyranine, you kind of strip most of the stuff off. So all you have is this carbon skeleton. And then that gets turned into glucose. Really kind of interesting. I think it's on the next slide. It may be 2 slides down. We're going to explore this other pathway, because from the little description here, where alanine could go here to the glucose and follow this cycle, it can also go off in this other direction. And when it says urea, you think, okay, you're going to pee it out. But there's a whole cycle there that it can go to that does not mean that it actually is ending up in your pee. So that is, as I say, on a slide to come. And I think I've described everything that is over here. And let's go to the next slide. Okay, so this is just to sort of reinforce and summarize some things that I've already said. Alanine activates an enzyme that increases the energy production in your cells. Well, that's actually, I think, on the next slide. But what alanine is going to do in this other pathway that we're going to look at next, when it goes to increase energy production in your cells, the result is that you get a reduction of blood glucose. And it's a reduction in blood glucose that does not involve insulin, so no drugs. And I don't know how far they've gone in actually making practical use of that observation, but it does help prevent low blood sugar in the body. So I'm sure, there's a lot of research in this area going on. Okay, so here, what I did in the bottom here is just take this picture of the liver from the previous slides. You can see the alanine coming in, and we talked about the glucose going out. Now we're going to look at this other pathway. So this slide is taking us from alanine to the Krebs citric acid cycle. Now, back when I was in school, I had to memorize the Krebs cycle, the whole thing. at least for 2 different exams that I could remember. When you look up the Krebs, if you go Google the Krebs cycle now, what comes up is something called the citric acid cycle. Well, I had seen the citric acid cycle in these figures before. I never knew it was the Krebs cycle, so I didn't know to be excited about it. But now I have seen that these are 2 the same thing, and so we're going to wander our way across this path and down to the Krebs cycle, I will call it. So there's 2 big things happening as we follow this pathway out of the liver into really the mitochondria of every cell. So when the alanine gets transformed along this pathway, it is converted into a molecule called glutamate. And I are going to talk about the practical significance of this pathway in the next slide. But you can see from this picture that we have this molecule that comes out of the liver, and it can go to glutamine or it can go to GABA, and it goes around in this circle. And as I say, I'll talk about this part of it in the next slide. And that particular part itself is very important. I've talked about it in other talks. I'll just remind you. But it can also come down into this other path, which drops it into what's called the citric acid cycle. And that's a series of chemical reactions that release the stored energy from carbohydrates, fats, and proteins. Now, you can get to the way you learn it, or the way we used to learn it in our initial biology classes. We pretty much talked about carbohydrates. If it was coming in as sugar, and we learned what happened in this cycle to give us energy that you could actually use. We never talked about it in early biology classes of you're getting material from your liver, the recycling system that's coming into this process and ending up giving you energy that you can use. And so this, I think, at least to me, comes a long ways in explaining quite a bit new. So I want to show you a picture of just how important it is that you are feeding this process here, the glutamine, glutamate, GABA process. And as far as the citric acid cycle is concerned, I'm just going to leave it at this point because that's a long, messy cycle, and we don't want to spend an hour on it. Here is the glutamate and GABA exchange. So glutamate's the green, so it comes up in the morning. It's your, like, putting on the gas molecule. It's waking you up, getting you ready for the day. The GABA, and at the same time, the GABA is going down. And as you get close to the evening here, the GABA comes up. This is the settling you down, making you relax, making you want to go to sleep molecule. And it's coming up when the glutamate is going down. So these 2 molecules interacting together along those lines are really, really important for your diurnal cycle and for your night to be night and your day to be day, and life to really go on in a well-balanced way. Now, in terms of the brain, and the fact that alanine is important for the transfer of ammonia. So again, remember I said you've got these nitrogen atoms in alanine, and that has to do with getting ammonia out of this glutamate GABA cycle and into the glial cells. Well, what are the glial cells, and why do you care about them? Here they are down here. Look, they're very beautiful, and at least however they've been colored. And they are responsible for maintaining homeostasis in your neurons, support and protection, and they form the myelin sheath that protects your neurons. They also metabolize glucose to lactate, which is, we think of lactate, we think of our muscles, but lactate is what photoreceptor neurons want to have as fuel for their metabolism. So our neurons want to eat, want to utilize lactate as opposed to strictly glucose, and this glial cell helps us do that. So the alanine is important. There are other things that contribute to the glutamate GABA activity, but alanine is important for the consequences of that activity in the brain. I guess that's the way to summarize it. Now, as I say, we should talk about copper at some time. And so here, I'm sure you don't remember what the AHK molecule looked like on the early slide that I showed. But if you sort of look at my cursor, and I'm going to trace it down here to the carbon in the middle, and then trace it out the other side, and you could see that if you cut that molecule in to right where the copper is and let the copper go, what you have on the bottom is an alanine, and what you have on the top is an alanine. Alanine, well, it's the whole thing. The alanine's the AHK on top and bottom, and why they use K to abbreviate as an abbreviation for lysine, I have no idea. It's most confusing, but you have a full AHK molecule on one side and another AHK molecule on the other, and in the middle it holds this copper molecule and it gets it where it needs to go, as it also does with nickel and zinc. As I say, we spent a lot of time on the last talk on copper. I still will say just a few things. That is that all organisms need copper. And it doesn't matter, all organisms that have a nuclei in a membrane. So whether you're a microbe or a human, you need copper. And here's a short list of what it's required for: iron metabolism, oxygenation, neurotransmission, embryonic development. And not only is it important itself, it also does signaling, as for stem cells, which will not differentiate if there's not enough copper around. So for a longer discussion, you can go to the talk on X49. And I think I will skip this slide, which does have things at the X on it. If you're interested, you can come back to this at a later date. It mentions a lot of things that are not mentioned on the X39 talk, such as the production of melatonin. It's important in blood clotting, and well, cellular respiration. At some point, we're going to talk about cytochrome C, because David Schmidt always does, and therefore, actually, I think, so this is the last talk of this season, and I'll start up again after Labor Day. And my early talk talks about communication. My first talk will review communication systems in the body. And we're learning more about the relationship of cytochrome C in that. Because if you, this is a teaser, I'm giving you an advertisement. Cytochrome may connotate to you chrome, light. You know, this is important for light, and Lifewave is light, and so we're going to make these connections, which I wasn't sure that that we'd make before, but I can see it coming together. So just expect some more information about how Lifewave light actually transmits through and works in your body next fall. And with that, I will skip to we're now moving into the section of the talk that deals with the studies that have actually been done on this copper peptide, either by Lifewave or by others. And GHK-cu, the X39, which is stimulated by the X39, shares with AHK-Cu the fact that there's a whole lot of research on skin in the skincare industry on it, and it shares it having some qualities with respect to the growth of hair. There's not so much, when we talk about the X39, we go right from talking about the hair growth into the stem cell production. And that connection really hasn't made as firmly or at all with X49, but it sort of seems like it should be there. So we will also be on the watch for that. But what is established is that it's involved in the health of the vascular endothelial cells. And so we come back to the importance of AHK in the vascular system. And Melinda Connor is the primary bench scientist who's doing current work on the Lifewave products, and her research is pretty comprehensive. So Lifewave's own research, this is a statement from them, which is pretty vague. But you see that the statement from them talks about its importance in its ability to metabolize the amino acid alanine. And so we come back to David sort of suggesting that the key benefits, as far as he has seen them and or as he designed them, center around the alanine molecule here. So again, these are Lifewave studies now. They had a 20-person study, and they documented a reduction in blood pressure using X49 only. The systolic blood pressure decreased by 5.5%. If you used X39 and X49, they got decreases in both systolic and diastolic blood pressure, and this again speaks to the effect of these molecules, these patches. This is looking at the patch directly of these patches on the cardiovascular system. In terms of exercise, again, they were particularly interested in this because of the alanine glucose cycle. That X49 alone, you could do more sit-ups, you could do more push-ups, you could do more squats, you could do more bicep curls, and you had stronger grip strength, and all of that's great, except I don't approve of this kind of masochistic treatment of your body. But if you're into that, or if you just want to use it to measure the body's ability to produce energy, then it's important in that respect. So these are the same figures for X39. Well, X49 alone, this is a study on a bike, again, the exercise bike in the lab, and you burn more calories, you go faster, you go for a longer time, and your pulse stays lower. And if you combine the X39 and the X49, everything is more intense. So this speaks to the whole component of energy production, of the patch providing energy production in a quite coherent way. So their data is showing that X39, X49 both help to build better bodies, but they do them differently. X39 makes the body leaner and stronger. Adding 49 increases fat loss and creates more change. X49 strengthens the bones, which we didn't talk about explicitly, but I've heard Melinda Connor, Dr. Connor talk about it. And with X49, one recovers more quickly, regardless of your age. So, on the back of the neck, under the belly, I would like to remind those of you who maybe haven't heard David say it, that the company is only allowed to advertise or promote or recommend the patch placements that they actually used in their studies. And of course, a lot of these were done, a lot of their original conceptualization of how the patches would move through the body were based on the acupuncture meridian system. And there are other people outside the company who are very actively looking at other placement, other ways to patch that make use of the meridian system. And so if you are interested in, you can just use the places that the company recommends, but if you're interested in sort of more specific targeting, then there are, you can be in touch with me or with, we've got Rebecca here, and she's been looking at that. So be in touch if you're interested in the meridian system approach to patching. I think that it brings me to my disclaimer, which is the patches don't claim to make any medical cures, no diagnose, treat, cure, prevent diseases. If you have a serious, if you have a disease, you need to talk to your doctor and consult with them about how these patches might be used to help in the treatment program. They are wellness patches, and they are designed to support your health and well-being. So with that, I will just report that I wear the X49 patch a lot. In particular, I'm pretty religious about it because I think it's really important. My husband has cardiovascular issues, and so I make sure that he's using it. He had a heart attack a couple of years ago, and went for several years with intense pain in his calf muscles whenever he would try to walk, and that has pretty much gone away. And the vascular surgeon has reported that the blood pressure in his legs has normalized without having to do any surgery to his legs. And so we're pretty happy with the patches. And with that, I will just let you know that my talks can be found on my YouTube channel, which they now have handles, I guess is the right new modern way to talk. I have a handle called @NancyFlournoy, so you can find me there on YouTube. And I have a website that needs updating, but there's some interesting information about myself there called lightpatchscience.com. So I hope to see you next fall when we start again and extend each of these. Thank you very much.
Thank you, Nancy. Yeah,
So I
great
will stop
presentation.
sharing.
Nice
Now I
job.
can't see anybody there. Wait a second.
There we are.
Huh. I don't know what you're seeing, but I don't see you.
We see you.
Oh,
We
good.
see you if I mean. I just have to hit the camera.
I have to hit it harder. I've had problems with my Mac. It's been not working well. I'm using my husband's Mac and his keyboard is not very reactive, so I have to really pound on it. So thank you all for coming. Maybe I'll take a question or two on the recording and then stop the recording. So does anybody have something they want on the recording?
No, I've been feeling pretty good. Spring's around the corner, and you know, I'm ready to get out and move around a lot more.
Okay, well, let me turn off the recording.